Okay, guys, example number 4 here. Now, Aaron asked a very good question in between our recordings, and we were talking about solving, and I'm going to get to that in just a moment. Okay, if it has an equal sign, then I can solve this thing. All right, and you guys already know how to solve. You could use the quadratic formula to find out what x is. But I'm going to erase this for the moment. We'll come back to the idea of solving in just a minute. All right, but let's factor this. Nothing in front of the x, okay, except so I know it's 1. So I know that the two front terms in each binomial are going to be x's, all right, x times x. Now we've got something a little bit different. This is minus, so I know at least one of the factors has to be a minus, right? And since this is a minus, I know that it is just 1, all right? So I know that the other one's going to be positive, because only when I multiply a negative times a positive do I get a negative, okay? So let's look at negative 20, all right? Now, it could be negative 1 times 20, or it could be 1 times negative 20. Now I'm almost doubling the pairs, or I am doubling the pairs, because either one of them could be negative. We have to see which pair gives us the right middle term. It could be negative 2 positive 10 or 2 negative 10. All right, either of those gives me negative 20. It could be negative 4 positive 5 or 4 negative 5. All right, so let's just take a moment. We're going to add these up. This gives me positive 19. This gives me negative 19. This gives me positive 8. Oh, that should be an equal sign. And this gives me negative 8. This gives me positive 1, and this gives me negative 1. And I'm looking for negative 1. So the one that works for me is this last pair. All right? So when I fill it in, I'm going to write, oh, let me do it in red. No, I'll do it in blue. Plus 4 minus 5. Okay? And then it's factored. Now, like Aaron was saying, or Aaron was asking earlier, he said, what if we were trying to solve this thing? Why does it help out if we're trying to solve it? Well, remember, if I've got two factors that multiply to give me 0, that means if either one of these things is 0, then it's a true statement. Well, I'm going to look at this first binomial. X plus 4 equals 0. So if I subtract 4 from both sides, I get x equals negative 4. So that's one of them. Okay? If the second one equals 0, right, x minus 5 equals 0, I just add 5 to both sides to show me what x has to be. X has to be 5. So my solution set is x equals negative 4 and 5. Now this one didn't ask us to solve it, but that's why we're trying to factor, because it does make it easier for us to solve it. Also, when we're working with rational expressions, that is fractions, with polynomials, it's much easier to factor these things and cancel out. So that's going to help us out later as well. So factoring is a big part of what we're doing right now and what we're getting close to doing. All right, James P., a quick question. What you got?
Yeah, it doesn't matter if the negative 4 and negative, I mean the positive 4 and negative 5.
Now, I hate to say this, but James has asked this question before. He said, what order does this need to go in? Guys, remember, with multiplication, it's commutative, right? And that means that 2 times 5 equals 10, and 5 times 2 equals 10. It doesn't matter if I put the negative 5 in the front or the back, okay? Usually, I think books put the bigger number for the binomial in the front, but it doesn't really matter, okay? If I multiply it out, I'm still going to get the same polynomial. Okay, a follow-up question, James P.
No, I meant if the 4 is negative and the 5 is positive.
Yes, if the 4 were negative and the 5 were positive, then that would give me a positive x in the middle. But I don't want a positive x. I want a negative x. Okay? If I add them up, because they have to add to give me the middle term. Yeah. Patrick.
It says x equals negative 4 and 5.
X equals negative 4 and 5. Am I wrong on that?
No, because shouldn't it be 4?
No, no, no. These are the back terms of my factored, but that's not what x equals. Okay?
Oh, yeah, negative x.
Right? Okay. All right, guys, good job. And I think we're done with that.